OPA on AWS is an amazing open source project that allows you to build your internal developer portal and platform using Backstage and AWS and make your developers self-sufficient and much more effective. We are launching a new working group in the Platformers community for OPA on AWS and we want you to join. But before that, we want you to get to know OPA a little bit better. So in this video, we're going to explain what is OPA and also demo OPA for you. Let's go. OPA on AWS stands for Orchestrate Platforms and Applications. It's an open source reference implementation for IDP that ties together AWS resources and enterprise-ready solution. By using OPA, you can enable your developer to be self-sufficient and be much more effective and focus on what they do best, which is write code and not manage cloud resources. Let's break it down and understand a little bit better what OPA means. Let's start step by step. The first thing is that it's an open source reference implementation or a suggested solution. So you can take it as is, you can use it and deploy it out of the box. You can also adjust it and change it based on your use case. So it's a really flexible solution, and what we want and encourage you is actually to change it and fit it to your needs. The second thing is that it's a solution to build IDPs on top of Backstage with AWS services. So what we want is essentially to make your developers to consume resources in the cloud, but they don't want to be experts or manage actually resources in the cloud. For example, they want to create a service, they want to create a database, they want to create a machine with GPU for, 2 days just for development and testing. They don't want to go into a console or they want to run Terraform code. They want to develop their own application. So OPA will allow them to go into Backstage and use the self-serve capabilities to manage AWS resources and create resources as the cloud infra team, the DevOps team, and the SRE team created them for them. So developers will be independent and can self-serve cloud resources while being much more efficient. And the last thing is that OPA is enterprise-ready solution. So there are many teams, especially enterprises and really secured restriction companies that want to use OPA. So it's built to run on those environments. So for example, you can use the authentication, authorization are pretty out of the box, encryption and security are out of the box. Everything that enterprise requires in terms of security and compliance already baked in. So like any IDP, we want your developers to be focused on code, focus on development, and we want you to focus on creating amazing platform. And this is what OPA is all about. How OPA works. Let's take a look on this high-level diagram. And I want us to focus on the right side, the application developers. What they want. They want to create their own application, they want to create business logic, and they want to focus on create the product they are working at. What they don't want is to manage cloud resources. So what they would do, they would go into the Backstage portal, they would go into the self-serve part, and they will just create and consume the resources they want in a very simple and easy way. But for that to happen, we need some other team, the platform engineering team, that they will create the templates, the tooling, the guide rails, the templates and the automation for the application developer to just consume the cloud resources in the easiest way possible. How they would do that? There are a lot of tooling that can be integrated into OPA and the platform to make that work. We can see a few examples in here. For example, for CI/CD, we can use GitLab, GitHub Actions, Jenkins, some automation tool and CI/CD tools that will allow us to run our templates and automations. We have the infrastructure as code tools that will allow us to manage our cloud resources. Obviously, developers don't want to create Terraform code. What they want is to create, database or S3 bucket. By clicking on the portal, they will be able to create that, and infrastructure as code will be provisioned for them. And also, where do we keep all of that? Obviously in a source control, so it can be integrated with any Git repository that you know. In high level, this is how OPA works. Let's take one step deeper and take a look on the next diagram. This allows us to understand a little bit better how OPA works behind the scenes. So on the bottom left side, we got GitLab. GitLab basically holds everything required for us to run OPA, to manage the infrastructure as code, and to run the action and the templates to make the cloud resources to be provisioned. So we keep there the templates, the pipeline, the applications themselves, the environments, providers, and resources. Everything required for OPA to work. Later in this video, we are going to talk a little bit deeper into what are environment providers and resources. A little bit on top of that, we can see OPA and AWS, which is the Backstage, already connected with identity provider, can be connected to any identity that you're using from Azure AD, Okta, or Amazon Cognito. On the right side, we can see the AWS account. So something really great about OPA is that it's a multi-account tool. You can connect multiple accounts. For example, if you have different business units working on the same platform, you can connect them together. Or maybe you have even account per customers, like a multi-tenant environment. All of them can be connected together. And the definition will be kept on GitLab. What is the environment that we want to create will be on GitLab. And then the GitHub action in this example will take that, provision that, and will create the cloud resources. So when developer actually logging in using Okta Active Directory to Backstage, they want to create, RDS, Lambda function, EKS cluster, they would go there, click on a button, the template and the pipeline will be fetched from GitLab, the action will be taken and run, and that will provision the cloud resources in AWS for the right account that was created. And this is the full flow. Like this is how we enable developers to go into Backstage, click on a button, and then a magic happens and AWS resources has been created for them. How OPA can be integrated with Backstage. As you may guess, Backstage plugins. Backstage got a plugin system that allows us to basically plug and play any plugin and system that we want into Backstage. It uses to create a really rich portal that can be integrated with many systems. One of them can be OPA on AWS. And OPA on AWS got 4 plugins required in order to work: the frontend, backend, common, and scaffolder. Basically, frontend and backend responsible for the frontend and backend. Common is a shared library between all of them, and scaffolder execute templates. All of them can be connected, and then it fetch information from AWS and also use the GitLab API in order to run templates and action and actually create the resources created by the users in the portal. OPA is a battery included solution. What does it mean is that after you deploy it for the first time, you need to do small configuration and you are ready to use. There are pre-baked templates and configurations that let you create AWS resources 10 minutes after the first installation. They also can be customized. So in most of the cases, your platform team will take those templates and adjust it based on the needs and the configurations in your organization. And this is what good thing about OPA is that it allows you to get ready and run pretty fast. And on the other side can be customized and adjust for whatever use case needed. On the website, there is the documentation with features allow us to see which features actually comes out of the box when we are using OPA. So let's take a look on those. And what we can see is that we have the application section with ready to use the application. We can see that we run on Kubernetes, Node.js application, Python application, with RDS, without RDS. We can run serverless application, and we can also use AI RAG implementation over serverless implementation. So we have like pretty wide varieties of application ready to be used and ready to be adjusted to what we want to achieve. But in order for them to run, we need to configure what is the Kubernetes cluster, what is the serverless configuration that we want this application to be run on. And for that, we got the top section called providers. And providers basically allow us to configure what are the providers and the infrastructure that the applications are going to run on. So in the most cases, we will configure a provider and then the application will be created on the provider or using the provider. We also got some shared resources like RDS database and S3 bucket. The main thing is that those are always changing. So you can go into the website a month or 2 months from the time I've created a video, and then you will see completely different application and templates. They are not completely different. They are a little bit different. They are always being added, but you can maybe get closer to what you want to achieve using those. So I really recommend to actually go and check it when you are watching the video. One more very important resource is the OPA on AWS GitHub repo. You can find there the code, the templates, everything you need in order to run and use OPA on AWS. There is also a really cool section with the latest updates and latest release. You can also open an issue and get the team feedback around the feature request or the bug you just requested. So basically, like any open source project, this GitHub repo is the main source of truth for everything regarding OPA on AWS. Highly recommended to check it out. In the demo today, we are going to do a few different things. Like the first of all, I'm going to do an overview about OPA, GitLab, and AWS and show you how they work together. Then we are going to be the platform engineering team, creating an infrastructure and cloud environment for our developers to come in and actually use it. And the last part of the demo, we are going to deploy application like we are developers on our environment using OPA on AWS. So let's do that. What we can see in here is a basic Backstage UI. We can see that we have the home button. We can see that a new section was added to the menu, which is the AWS, when we got the environment, providers, and applications. Later in this video, we are going to create all of them. It's a really good to mention that when we create a provider, it doesn't have to be AWS. We can code it and make it run on any cloud provider that we want. We do have also the projects in GitLab. So we have the GitLab repository that was deployed using the OPA provider, but we can change it. And basically, I know they're working on some GitLab integration and some other source control. But for this demo, we are going to use GitLab, and we have the Backstage reference, which got all the templates for Backstage available. So if you want, for example, to do a modification, change the provider, change the environment, change the application going to be deployed, you can come in here and basically change. So if you are going to take a look about AWS EKS environment provider, we can see the template available and also the content, which is actually the stack parameters, the catalog, everything needed for us to actually run EKS. So this is what you get out of the box from OPA. Also, we have the AWS console. Obviously, we are going to follow our resources being created on the AWS console. So the next thing we are going to do is basically to create an infrastructure for developers to deploy their application on. So let's do that. What we are going to do is that we are going into the AWS section. We are going to click on providers. What we can see is that we don't have any provider. So for us, OPA on AWS provide us with templates available, and using the templates, we are going to create our provider. So what I'm going to look for is I want to create an EKS environment, means that we are going to spin up a new EKS cluster, and then we can create an environment on top of that and let our developers to deploy their application on it. So I'm going to use AWS EKS environment provider. I'm going to click on that. I'm going to create this EKS dev, just a simple EKS development. Let's use the prefix definition, EKS for devs. Who is going to be the owner of that? The platform engineering team. I'm going to get my AWS account, ARN role. And I'm going to create a new VPC, and I'm going to use the default CIDR for that. We can choose whatever we like. I'm going to use a private access point. And we are going to use Fargate for that, make it easy to be deployed and to be used. So I'm going to click next. I can pick my repository name. That will be create a repository on GitLab. Let me just use that, review. And now we have the ability to review, and we are going to click on create. So what's going to happen next is that OPA on AWS is going to create a repo on GitLab, and using the GitLab CI, it will deploy it into AWS using CloudFormation. So we can click on Open in Catalog. That will allow us to see the environment provider created on the catalog. You can also get it from here, like AWS, providers, and now we have the EKS dev provider. And when we click on it, we get into this section. We got a lot of information available, and after the creation of the EKS cluster, more information will be added in here. We can go into the CI/CD section. That allows us to follow the deploy of the environment. So what's happening now is that GitLab actually deploying the EKS cluster, and after it's done, we will be able to see it as status ready. And we have the management, allow us to delete that if we want. It will also delete the cloud resources, which is really cool. So next, I'm going to show you GitLab. Let's refresh this tab. And now a new repository was added. Let's click on it. And we can see that we have very basic templates available. The GitLab CI, the stack parameters created for this specific provider environment. The Backstage and the infrastructure as code, which is basically a CDK code that actually create the stack in the EKS cluster. So that looks pretty cool. We got all the information in here, and those were created while we launch the template to create EKS environment. If we are going into the build jobs part, we can see the job that actually create the EKS environment. We can see it's running. It's going to take a while. If we want to follow that, we can always go into the AWS console, go into the CloudFormation, and we can see that we have this stack creating progress. If you want, we can follow it in here. We can go into the resources and see all the resources basically in creation. So it's going to take a while, something like 15 minutes if I remember correctly. So what I'm going to do is I'm going to stop the video. We have like the stack created. We can see that the job is done on GitLab, and we can also go back to the providers in the Backstage OPA and see that we have a new provider, the EKS dev environment, which is ready and up and running. And that's great. That means that we have the EKS cluster to run an environment on. If I'm going into the AWS console to the EKS service, we will see that a cluster was created, and we got a cluster that the application that we are going to deploy later today is run on. So the next step for that would be to create an environment. So a provider is actually the infrastructure, the EKS or ECS or whatever infrastructure we are going to run our application on. The environment actually represents an environment. It can be a production, dev, run region or the other that can be easily abstract the infrastructure from the developers using it. So when you're trying to create application, you just select which environment that you want to run on, and a provider will create the resources on the environment you requested. So what we're going to do next is that we're going to create a new environment. We are going to do that using the templates. So I'm going to create an environment. We have this AWS environment, which is a generic one. And what we're going to do is that we're going to do dev Kubernetes, okay, it's environment. We are going to make it the short name as the development Kubernetes environment. We are going to make it EKS. We don't need approval for deployment. It's going to be also owned by the platform engineering team. Everything is going to be simple, single account, single region, development. We are going to make it public so everyone can use it within our organization. Hierarchy is how much important it is, how much it's higher on the level. We are going to make it development environment. And now we're going to click on next. What is going to be our environment? So it's going to be dev Kate's environment. review, and create. And now it's going to create the environment. Obviously, what's going to happen is that it's going to create the environment in the catalog. It's less of real resources being created. It's more of our abstraction layer. So it means that we have a new repo, dev Kubernetes environment, really simple and basic one. And after we got the environment, we can actually deploy our application on. Let's do a quick refresh. Cool. So what we're going to do next is that we're going to create our application. So we don't have any application at the moment. And now we are switching into being a developer in our organization. What does it mean? It means that now we are a developer coming into Backstage, and what we want is basically just to deploy, a simple application or on our EKS cluster. I don't know much about EKS clusters or Kubernetes environment, but what I want is basically my application to run on. So I would go into the templating section, like the creation part, and what I'm going to search in here is a Kubernetes application. So we have a few applications available: Kubernetes with RDS, Python Flask Starter, and Java Spring Boot Web Service. So I'm going to take the most simple one, the Python Flask Starter application, and I'm going to choose it. So what I need to do is basically to decide what I want, what the name's going to be. So let's call it Flask App, and the owner going to be developer. Kubernetes namespace if we want. Let's pick a namespace. Call it Flask. And we're going to create a separate role for the Kubernetes namespace. Git repository, app Flask. It can be, by the way, any application. I'm calling it Flask just because it's a Flask app simple application. Review and create. And now the application is going to be created. So what's going to happen is that, first of all, a new repo will be added to our GitLab. We can click on the open in catalog and see it in here. And what's going to happen is that very soon it's going to deploy our application on our EKS cluster. If you're going to take a quick tour around our application that was created, we can see a few things in here. One is that we have the AWS deployment provider. That's allow us to manage on which provider this application is going to be deployed on. The Backstage information, the infrastructure as code, or what is the CDK using in here to deploy this application. Kubernetes, I guess those are the resources being created, like the deployment or whatever Kubernetes resource is going to be created, and also the server py code. So what's going to happen next is that, as you may guess, the pipeline is going to run. We can take a look on it. And what's going to happen is that the pipeline is going to deploy. Oh, it just finished. That's cool. Oh, okay. So one finished creating the CI stages, and now it's going to create basically the Kubernetes deployment. What happened is just I waited a few minutes and everything was created, like a few CI GitLab run with the creation of the deployment, the AWS credentials, building the image, and then committed and waited for it to be deployed. If we would go into our Flask application in Backstage, by the way, it added in here as an application. You can click on it, and you can see all of the information about your own application. For example, who is the owner, the relationship, if you want to clone it, and the repository access token, the state of the application, so we can see where is it running and what is the current state. So we can see in here, for example, let me zoom in a little bit, that it's running. 2 out of pods are ready, and when it was last updated, we can see the environment variable available, and also information that was added after the creation. For example, which ECR repository is this image built in or resides in. ELB used by that, and etc., which is cool information regarding the cloud providers. Developers don't really care, but sometimes when they need assistance, it can help people to come in and understand exactly what's going on. CI/CD, we can see all the run that we just saw in GitLab, which is cool, or the contributors, languages, and general information from the GitLab repo. And what is really exciting is that we can also see the logs in here. So it's already integrated with CloudWatch, and we are able to basically get the logs of the application. So we can click in here and it will load. I'm in dark mode, so it's a little bit hard to see that, but we can see all of our logs available. And what is amazing is that we were able to, first of all, as platform engineering, to create the infrastructure, the Kubernetes cluster, and the environment for developers to develop their application on. And then, as a developer, we were able to come into Backstage, just declare that we want an application, click on a few wizards, and from that point, we already got application running in EKS cluster, in whatever environment we decided on, and that's extremely amazing. So that's it for the demo. If you want to explore more, you can go into OPA website and learn more about OPA and how it can be used. Obviously, I showed you only a few examples, but if you go to the create, you can see that a lot of templates are available, as we explained before, from environment providers, and also other templates for your own application. Just pick and choose whatever you like, and you will get your own OPA environment up and running. In the Platformers community, we got a working group for OPA on AWS. We want you to collaborate and join the community and to get involved with the people that using and building OPA on AWS. We got in our website all the resources required for you to join the working group. We got a dedicated Slack channel where you can ask questions and answer questions from other people about OPA and AWS and actually communicate with everybody involved. We also got a monthly working group meetings when you can join and actually hear the latest update and collaborate with other users of OPA on AWS. We want you to get involved, so what you should do next is go to the website, go and join the Slack channel, and then go and register for the next monthly meeting. Thank you very much.